Now that we have seen the algorithm for exponential searching algorithm, let's try to write the Python implementation for it. So inside the searching folder, I'm going to create a new file called exponential search.py. Okay, here I'm going to define a class called exponential search, and here I'm going to define a function called exponential search. It will basically take the array and the value that user wants to search. Now, as part of the first step, we will need to find the range. For finding the range, what we did when we discussed the pseudocode, we defined a variable called start index. Okay, in the start index, we are starting with the index 1. Now, as long as this start index is less than the length of the array, and whatever the value we have at start index is less than the value that user has passed, in such cases we will simply update the start index with start index into 2. Okay, once we complete this loop, right, whatever the value we have inside this start index variable could be the maximum or the end range for the binary search operation. So using this start index, we will have to find the minimum and maximum for the binary search that we are going to perform later on. So the minimum index or the starting index for the binary search will be start index divided by 2, because in Python, if divided by 2, it could give the floating point values, right? So I will simply import math library and I will simply use floor operation on it. So math.floor of this. Okay, and the maximum or the ending range for the binary search will be whatever the minimum of the start index comma length of the array minus 1. Why I did here min is because if you observe the range logic here, right, as we continue updating start index with start index into 2, the range could go beyond the length of the array. That means that we will end up searching the indexes that are not available inside the array if we are not, taking care of this. So if we try to search the indexes that are not in the array, we'll obviously get the array index out of bound exception, right? To overcome that, the maximum value that we could pass for the binary searching is the largest index inside the array, which could be available inside the starting index or inside the length of the array minus 1. Okay, this is just to handle the case when the start index overflows the length of the array that we have here. Otherwise, whatever the value, if it is less than the largest index inside the array, that itself we will use as a ending index for the binary searching algorithm that we are going to call. Now using this, seems like here the variable conflict is there with the min and min, so let's simply name the variables as start and end. Okay, now what we will simply do is we will simply call the binary searching algorithm. So previously we have already implemented, right? Let me just grab that piece of code here and let me just paste it. Okay, but if you see this binary search implementation, right, the starting index is nothing but min and the ending index is nothing but max, and since we are trying to find the value in the entire array, we passed 0 as a starting index and the max or the ending index as the largest index, which is nothing but length of the array minus 1. But in our case, we have already calculated these two based on the range operation that we have calculated, right? So for that, I'm going to modify the function declaration or signature to accept this min and max also, which are available inside the variable start and end. So I will simply modify this signature and I will simply call the binary search function from the exponential search function that we have written. So for binary search, the first argument is array and the second argument is value and the Third argument is the minimum index, which is available inside the variable start, and maximum variable is available inside the end variable. Okay, and this binary search will anyway return the index at which the value is available, or -1 if it is not available. So we will simply return whatever this function is going to return. Okay, so this is how we actually implement the exponential searching algorithm. So first we will find the range using the start index variable, and from that we will calculate the starting index and ending index for binary search, and we will simply call the binary search operation that we have implemented. Now let's just call this function and see if it is actually working according to the algorithm or according to the implementation that we have discussed. So let's say the array will be 1, 2, 3, 4, 5, 6, 7, and the value that I want to search is, let's say, 3. Now let me just create an object for exponential search equal to exponential search es dot, let's call the exponential search function, let's pass the array and let's pass the value, and it anyway is going to return the index, right? So let's store it in index variable and let's simply print it. So index. Let me just call this function and execute it. So for that I'm going to call Python 3. Inside the searching folder, let's call exponential search.py. So the output that we have got is 2. At index 2 we have the value 3. Okay, so we got the output. Let's say I want to search for the value 7. So if I simply call it, okay, I got the index 6 which got the value 7. Let's say I want to search for the value 17 which is not available. So if I call it, I'll simply get -1. Let's say I want to pass the smallest value that is not available, and if I execute it, I'm getting -1 which is not available. Since we are starting index with index 1, let's say I want to search for the value at index 0. Let's say the value will be 1. So if I execute it, I should get index 0. Okay, I got the index 0, 2. So it is working for all the cases that could appear possibly. Okay, so this is how we actually implement the exponential searching algorithm using Python.